You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we explore how digital information is measured and understood using standard storage units. You'll learn the difference between bits and bytes, how each unit scales into larger quantities like kilobytes and megabytes, and where these units appear in everyday computing. Whether you're managing files, comparing storage devices, or interpreting exam questions, understanding this measurement system is essential. These units define how much data can be stored, transmitted, or processed in nearly every IT environment. Digital storage units appear in Domain 1 of the ITF Plus exam, specifically under units of measure. You may be asked to recognize terms like megabyte or gigabyte, match a unit to a file type, or convert between values. The exam may also use real-world examples, such as estimating video file sizes or comparing RAM to storage capacity. That's why this topic is more than just terminology. It's a practical framework for understanding the scale of digital systems and the data they handle. Let's begin with the bit. A bit is the smallest unit of digital data. It holds one of two possible values, -0 or 1. Every computing function, from processing logic to storing files, is ultimately built on these binary values. A single bit represents a simple condition: on or off, yes or no, true or false. While one bit can't hold much information on its own, it becomes powerful when combined with others into larger units. Bits are the foundation of binary systems. A byte consists of 8 bits. It's the standard building block for measuring digital storage. One byte can represent a single character, such as a letter, number, or symbol. For example, the word data consists of 4 characters, or 4 bytes. Every file, application, and system component that stores information uses bytes as the fundamental counting unit. Whether saving text or transmitting commands, bytes are the language of digital memory. It's important to distinguish between bits and bytes, especially since they're used in different contexts. Bits, usually shown with a lowercase b, are commonly used to describe network speeds, such as megabits per second. Bytes, shown with an uppercase B, are used to describe storage size, like megabytes or gigabytes. Confusing the two can lead to major misunderstandings, especially when evaluating transfer rates or calculating download times. The distinction between bit and byte is a detail you can't afford to overlook. The first step up from a byte is the kilobyte, abbreviated as KB. A kilobyte equals roughly 1,000 bytes in decimal terms, or 1,024 bytes in binary. This unit is typically used for small documents, configuration files, or text-based data. A single email or Word document often falls within the kilobyte range. For many learners, the kilobyte is the entry point to thinking about data at scale. The next unit is the megabyte, or MB. 1 megabyte equals approximately 1,000 kilobytes. This unit is commonly associated with digital photos, music files, and mobile applications. A single MP3 song or high-quality image might be 2 to 5 megabytes in size. In many cases, MB is the unit where most consumers begin noticing storage usage, especially when dealing with email attachments, downloads, or cloud storage limits. A gigabyte, or GB, equals roughly 1,000 megabytes. Gigabytes are familiar to most users because they're used to measure RAM, USB drives, game downloads, and streaming video quality. A modern smartphone might have 64 or 128 gigabytes of storage, and streaming a full-length movie might consume 2 to 3 gigabytes of data. Understanding this unit is essential for interpreting device specifications and estimating data usage. One step above is the terabyte, or TB. A terabyte equals about 1,000 gigabytes. This unit is common in hard drives, backup systems, and large-capacity external storage devices. A typical desktop might include 1 or 2 terabytes of internal storage. Businesses, creative professionals, and gamers often work with files and systems that reach into the terabyte range. TB units are useful for describing high-capacity local storage environments. Beyond the terabyte is the petabyte, or PB. 1 petabyte equals 1,000 terabytes. This scale is primarily used in enterprise settings such as data centers, research institutions, and large-scale cloud services. While it's rare for personal computers to manage petabytes of data, this unit is becoming increasingly relevant in industries that process high-resolution images, scientific data, or machine learning models. The term PB may appear on the exam in examples involving large-scale storage. There is an important distinction between binary and decimal labeling of storage units. In binary, 1 kilobyte equals 1,024 bytes. In decimal, which is commonly used in marketing, 1 kilobyte equals exactly 1,000 bytes. This means a device advertised as 100 gigabytes might show slightly less when viewed through the operating system. The exam may reference either format, so understanding both contexts helps you interpret questions more accurately. Manufacturers typically advertise storage in decimal units for simplicity. Operating systems, on the other hand, report storage in binary units. This discrepancy is why your hard drive may appear to be smaller than expected when viewed in File Explorer or System Settings. Knowing this difference prepares you for questions about storage reporting and helps you answer confidently when asked to explain the discrepancy between advertised and actual capacity. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. As you begin estimating file sizes or understanding system capacities, it's useful to match real-world content with its most common storage unit. A simple text file, such as a configuration setting or a plain document, typically falls into the kilobyte range. A high-resolution photo or a compressed audio file like an MP3 often measures a few megabytes. A high-definition movie might require several gigabytes. These estimations allow you to judge whether a file will fit on a flash drive, how long a download might take, or how many files your storage device can hold. Random access memory, or RAM, is usually measured in gigabytes, just like many types of consumer storage. But the function of RAM is completely different from storage drives. RAM temporarily holds data for applications that are currently running. When you open a web browser or run a game, the program is loaded into RAM for faster access. Storage devices like hard drives and solid-state drives, on the other hand, retain data permanently, even after the power is turned off. Confusing these units leads to mistakes in system evaluation. While petabytes are rarely encountered in personal computing, they play a major role in enterprise-level infrastructure. Data centers, cloud providers, streaming platforms, and research institutions generate and store petabytes of data regularly. Think of the vast amount of footage uploaded to video platforms, the high-resolution images used in mapping systems, or the historical archives preserved by academic organizations. These large volumes of data require systems that can store, retrieve, and back up massive amounts of information efficiently. Bits and bytes also appear in different parts of the computing environment, especially when comparing storage and networking. Storage capacities are always measured in bytes or larger byte-based units. However, network speeds and data transmission rates are measured in bits per second. For instance, an internet connection might be rated at 100 megabits per second, while a flash drive holds 64 gigabytes. Knowing which unit you're looking at prevents incorrect assumptions about download time or storage limits. It's important to understand that not all prefixes mean the same thing in every context. In marketing, decimal prefixes like kilo, mega, and giga follow powers of 10. 1 kilobyte is marketed as 1,000 bytes, but in computer science and operating systems, the binary interpretation is often used, where 1 kilobyte equals 1,024 bytes. These small differences compound over large datasets, which is why storage devices often appear smaller than advertised once formatted or viewed through the operating system. The ITF Plus exam may test your understanding of units in several ways. You might see a question asking how many kilobytes are in a megabyte, or how many gigabytes make up a terabyte. Another common format is scenario-based. A question might describe a file and ask if it fits on a device with limited space. You may also be asked to identify whether a number refers to bits or bytes based on its usage context, such as a speed rating or a file size indicator. These questions test not only terminology but also practical application. Being able to visualize the full progression of units helps solidify your understanding. Start with a byte, then scale up to kilobyte, megabyte, gigabyte, terabyte, and petabyte. Each step increases by roughly a factor of 1,000, though binary math may shift the exact number slightly. This progression is not just important for passing the exam, it also supports your ability to estimate download times, choose the right storage device, or interpret capacity labels on modern hardware. Mistakes involving digital units are extremely common, even among experienced users. A frequent error is confusing megabits with megabytes, which leads to vastly incorrect estimates of how long a file will take to download. Another mistake is assuming that RAM and hard drive space are interchangeable. RAM is erased when the computer turns off, while storage persists. A third misconception is assuming that advertised drive capacity is fully usable, without accounting for binary conversion or system file allocation. To build confidence in this topic, use a study strategy that includes both recognition and estimation. Memorize the sequence of units and the approximate scale between them. Practice estimating file sizes based on their content. For example, if a photo is 5 megabytes and a drive has 100 gigabytes free, ask how many photos will fit. Review specifications of actual devices, such as smartphones, tablets, and USB drives, and match the units used to the types of data typically stored on them. Active comparison is another helpful technique. Take a small spreadsheet and list a few file types, then guess their approximate sizes in kilobytes, megabytes, or gigabytes. Next, look up the real values and compare them to your estimates. This activity helps bridge the gap between abstract unit names and their real-world meaning. It also reinforces memory by giving the units context, turning them from memorized labels into practical, usable tools. Many learners find it helpful to associate each unit with a metaphor. A byte can be a single letter or character. A kilobyte is like a paragraph of text. A megabyte is a song or a photo. A gigabyte is a full-length movie or a mobile app. A terabyte is a packed external hard drive. A petabyte is a corporate data vault or a cloud storage cluster. These metaphors provide visual anchors for your memory and help reinforce the relative scale of each measurement. Understanding how these units apply across devices helps clarify their use in IT. For example, when evaluating a system's specifications, you might see that it has 16 gigabytes of RAM and a 1 terabyte hard drive. This tells you how much temporary processing space the system has versus how much long-term data it can hold. When comparing internet service plans, you'll be asked to choose between options measured in megabits or gigabits per second. Each use of these units helps describe performance, speed, or capacity in meaningful terms. To summarize, digital storage units, from bits and bytes to petabytes, are the language used to describe data size, system capacity, and bandwidth. These units define how much information can be stored, transferred, or processed by a device or network. By learning how each unit scales, where it appears, and how to convert between them, you prepare yourself to answer exam questions confidently and interpret real-world specifications accurately. Mastery of these measurements supports every area of IT. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.